This is topic 1, video 5. In this video, we're going to talk about what a mole is and how to convert between moles and particles, moles and molecules, moles and mole ratios. So pretty much all the information that you learned about moles in 10th grade pre-IB chemistry, we're going to revisit here. So just like when you would say, what is a dozen? And you would say a dozen is 12. When we say what is a mole is 6.02 times 10 to the 23rd particles of a substance. In IB, we're going to represent that with the symbol L or Na. And that's listed in your data booklet, so you don't have to memorize that. So a mole specifically is the number of atoms in exactly, let's say we're talking about carbon, 12 grams of pure carbon-12. It's exactly how many atoms or molecules there are in 1 mole of the substance. So let's say you were to add up NH3, find the relative molecular mass of ammonia, we would say that it's 17.04 using the numbers from your data booklet. So that means there are 6.02 times 10 to the 23rd ammonia molecules in 1 mole, and they have a mass of 17.04 grams. So IB loves these new symbols that we just have to learn how to deal with. So molar mass is going to be capital M. We talked about molarity as capital M, so you kind of got to get that out of your head. We're going to be using moles per decimeter cubed for molarity. We'll talk about that later. But every time you see capital M, that's molar mass. And the molar mass is just the mass of 1 mole of a substance. So when we talked about relative mass, we said that there were no units. But when we talk about molar mass, the units are grams per mole. So you could write G/mole or G times mole to the -1. These are equivalent notations, and it's something that you should be familiar with, that you could either divide or you could write times mole and raise it to the negative exponent. So let's say you were trying to find the molar mass of water. We know that water weighs 18.02 grams by adding up 2 hydrogens and 1 oxygen. So the molar mass is 18.02 grams per mole, or gram times mole to the -1. So molar mass is pretty much the same thing as relative molecular mass. It's just that now we're adding units gram per mole, whereas relative molecular mass didn't have units. Okay, so we're going to get started on our conversions. First, we need to know that we could use dimensional analysis. That's the factor label method. And we'll definitely do examples in class where we use dimensional analysis, and I'll show you a quick example at the end of this video. That's probably what most of the pre-IB kids are used to, because that's what you did. You start out with what you're given, and you multiply by some conversion factor, making sure that your units cancel out. We also want to show you how to use the equations that IB may use so that you have an alternate way of doing problems. So really either method will suffice. So let's look at this other method. This is the equation was on your reference table in 10th grade. Moles equals mass over molar mass. But now we have to kind of plug in and accept that we're going to be using these symbols. So moles is N, mass is M, and molar mass is big M. So you need to be able or comfortable if you're going to use this method with rearranging. So if the moles is N equals M over big M, and you were asked to calculate the mass, which is just little m, you could put the N over 1 and cross multiply. So N times big M equals M. You also need to be able to find molar mass, which is big M. So if you look at the second row, if you wanted to get M all by itself, you would just divide by N. So if you choose this method over dimensional analysis, I'm absolutely fine with that. You just want to know that how to arrange or rearrange the equations. But you guys love to put things over 1 and cross multiply, so I'm sure you'll be fine with that. So we're going to run through 3 examples real quick of mole calculations. How many moles of water are present in 27.03 grams? So we have our equation that we just looked at. N equals M over M. So the number of moles equals given mass over gram formula mass. So the mass is 27.03. And we're going to divide it by the molar mass, which is 18.02 grams per mole. Then you just divide. Next, what's the mass of 4.40 moles of iron 3 oxide? So now we want to know what's the mass. So we rearrange our equation to M equals moles times molar mass. So you would take your moles, 4.40, and you multiply by the molar mass. To find the molar mass, you had to add up Fe2O3. How did you get Fe2O3? Well, you were given the formula iron 3 oxide. Iron is +3, oxygen is -2. When you balance your charges or crisscross, you get Fe2O3. So our final molar mass is 159.70. That gets multiplied by your moles, which was 4.40. For example 3, you're given 1.30 moles of an unknown compound. They tell you the mass is 20.9. They want to know what's the molar mass. You rearrange your equation, N equals N over M, to be capital M equals M over N. You plug in the numbers, and you're done. Another equation we need to be familiar with, or again use dimensional analysis, is that moles is equal to particles over 6.02 times 10 to the 23rd. So our formula is N equals capital N, which is going to represent the particles, over 6.02 times 10 to the 23rd, or the L value. So if we look at this first example, we have 3.01 times 10 to the 22nd atoms of carbon. We want to know how many moles this would be. So we're going to take our mole equation, N equals N over L, and we're just going to plug in the numbers that they gave us. So they told us that we had 3.01 times 10 to the 22nd atoms. That goes in the capital N spot. And they told us that we had 6.02 times 10 to the 23rd molecules. That goes in the L spot. Here's another example. How many atoms of fluorine are there in 2.5 moles of tetrafluoromethane? So if we rearrange our mole equation, we get that we could find the number of atoms by multiplying the moles times Avogadro's number, L. So you could say, okay, we have 2.5 moles, and you're going to multiply that by 6.02 times 10 to the 23rd, and that will give you the value of the number of moles. But the thing is that they want to know specifically about atoms of fluorine. So now that we have moles of the whole compound, we're going to multiply by 4 because there are 4 fluorine atoms. So what we just went through were calculations that involve moles. Sometimes we're going to use the mass of the substance and divide by the molar mass to find moles, and sometimes we're going to use the number of particles and divide by Avogadro's constant to find moles. Alternatively, you could use dimensional analysis, which we used in 10th grade. So for example, here's a problem where we're given 40 grams of aluminum. You start with your given, you multiply by your conversion factor. What is your conversion factor? Well, 1 mole is equal to the gram formula mass. So we have 1 mole over 26.98 grams of aluminum. This comes right off your reference table. Your grams cancel out. So remember that when you're making this conversion factor, whatever unit is down here has to match your given unit. So that those units go away, and then we're left with moles of aluminum. Let's say then we wanted to find atoms. Then you would, starting with your moles, you make your dimensional analysis. The moles go on the bottom so that your units cancel out and the atoms are on top. So that's probably the way that I would say you're more familiar with. You could do the same thing with mole ratios. We can continue to use dimensional analysis, and we'll talk more in class tomorrow. We'll go through examples, and you'll figure out what method you like or prefer. The last thing we want to talk about in this video is mole ratio. So when you're looking at a balanced equation, the coefficient in front is telling you how many moles you have. So let's say we're looking at this particular reaction where we're making water. We have 2 moles of hydrogen, 1 mole of oxygen to yield 2 moles of water. The ratio of hydrogen to oxygen to water is 2 to 1 to 2. The ratio is fixed. So let's say we were to change the moles of hydrogen. We had 0.2 moles of hydrogen. Well, then you would only need half as much oxygen, or 0.1 oxygen, which would yield 0.2 moles of water. Or if I had 5 moles of hydrogen, the ratio would be 2.5 moles of oxygen and 5 moles of water. So let's look at another reaction here where we're making ammonia. What's the ratio between nitrogen and hydrogen? Well, there's no number, but the coefficient in front of nitrogen would be 1. The coefficient of hydrogen would 3. So the mole ratio would be 1 mole of nitrogen to 3 moles of hydrogen. Okay, well, what's the ratio of hydrogen to ammonia? 3 moles of hydrogen to the 2 moles of ammonia. Or what's the ratio of nitrogen to ammonia? Well, we have 1 mole of nitrogen and 2 moles of ammonia. You could also use dimensional analysis to do this. So that would mean you could take whatever it is you've given, and you multiplying by whatever it is you're trying to get would be going on top, and the same unit as the given would be going on the bottom. So what do we mean by this? Okay, what quantity of aluminum hydroxide in moles is required to produce 6 moles of water? You start with what you're given. So the given here is 6 moles of water. Start by writing 6 moles of water. If I'm putting water in my given unit, that means water has to cancel out. So in this conversion factor over here in givens, I have to go up to my balanced equation and find water. I'm going to write the coefficient of water is 3. What am I trying to find? The goal of this is to find the amount of aluminum hydroxide. So I go to the equation. How many aluminum hydroxides are there? 2. So in the wanted, I'm going to put 2. So you start with what are you given? The units for the given cancel. So since we were given the units of water, that's why we put water on the bottom here. Again, we could also do proportion for this type of setup, and we could show you that tomorrow. So in general, what were you supposed to understand by the end of this lesson? We were supposed to understand what a mole is and understand that's a fixed number of particles and refers to the amount of a substance. We're going to use the letter N to represent it. We need to know the value of Avogadro's constant, or how to find it, or where to find it in the data booklet. We need to know that molar mass is going to be given the symbol M. We're no longer going to represent molarity with M, but molar mass. The units for molar mass are grams per mole. And be comfortable with this notation. We also need to be able to solve problems that involve grams to moles, moles to grams, particles, and the amount of substance.